Let's concentrate, people. 5.3 will be your favorite homework. It goes fast, it goes smoothly. There's only one thing to know, and you just repeat it again and again and again. Fundamental Theorem of Calculus, Part 2. We always start with Part 2. I don't know why in America they start with Part 2, but this is the easy one. So 5.3 is the one that everyone knows around the world, and Part 1, that's 5.4. We're going to do it on Wednesday, and it's also not too bad, but at least you're hugging something. That is so cute. Anyway, you guys always distract me, but kind of in a cute way. So let's learn how to actually find definite integral exactly. No areas, screw rectangles. Who cares about geometry if you can just integrate using this amazing formula? And I'll be teaching you this in Calculus 1, 2, and 3, if you take my classes, of course. So in Calculus 2, we're going to proceed right away from this moment. It's very natural continuation. We're going to go to 5.8, I think, and then 6.1. And in Calculus 3, we're going to do double integrals, A, B, C, D, and triple integrals, K, M, whatever. And you will love it. So that's the thing. You learn it once, and you get it. It's just amazing. So a function must be continuous. Continuous means left limit equals right limit and equals f of x, f of a at that point. That's on the exam, on the final exam. On the closed interval. And it has antiderivative there. Antiderivative will be called capital F, like we did before. Then, instead of finding areas and using approximation, or even we did limit last time and so on, why not to take integral from a to b, f of x dx, find antiderivative first, plug the top in, minus find antiderivative, well, you already found it, plug the bottom. So it's top minus the bottom. I'll be mentioning this terminology all the time. It's not necessarily how you're supposed to teach it, but I always do, and students like it. So let me make an interesting point of this. So basically, I wrote steps. You don't have to write them down. It's so natural. When you learn how to do it, it becomes very quick. Find antiderivative first, and then you find a difference. You plug the top, which is b, and your upper limit of integration, and you plug the lower limit of integration. Take the difference. So comparing to what we learned before, integral, let's make it more beautiful. Integral f of x dx has antiderivative called capital F of x. But then you add c, because we have family of antiderivatives. That's antiderivatives. So antiderivative means what? When you differentiate this capital F plus c, it gives you small f. That's the definition. Well, important note to make. Note. When I integrate indefinite integrals, okay, let me write down and explain that. Indefinite integrals. Indefinite integrals are the ones that have no a and b. When I integrate them or find them, it gives me a function. See, it's f of x, that's a function. So integral of sine is minus cos sine plus c. That's a function. But then we learn areas below the graph from a to b. Areas of the function, area is a number, a value, volume is a value, but it's just squares and cubes and so on. So that's an important difference. Note 2, let me make 1, note 1. And then note 2, definite integral. Definite integral. That is the integral that has limits of integration defined. Definite integral gives you a number or a value. It's a number. And that's a big difference. A function versus a number. Because we're defining a and b. And then we also plug them in, and then you naturally get some kind of number. Let me show you examples, and then I will explain to you more what the heck is going on here. But also, basically, I want to mention that this is a number. Well, the previous chapters, 5.1, that was a function, antiderivatives or indefinite integral. So on the exam, you will have both. Let's do it. And this is a classic example you will have on the final exam, on exam 1 for calculus 2, a final exam of calculus 2, and then double integrals and triple integrals in calculus 3. I will show you several examples, and then you will be happy about this. And the homework goes fast because it's more or less the same. You already know antiderivative of x squared. There's just one extra step was added to the situation. So let's do that. When I want to find antiderivative of x squared, I use power rule for integrals, which gives me what? X cubed by 3. Do you all remember that? So you must not go to calculus 2 class if you're bad with differentiation or integration. That's just a fact. That's just a fact. I would rather retake it. If I were you, I would retake the class to become very good at it and then go to calc 2. Then struggle, suffer, and fail anyways. People who passed calculus 1 without very good knowledge of differentiation or integration fail calculus 2 in the first week already. The first week they lost because it goes very fast. We assume you're very good at it. And I will send you preparation files over the winter as well later, so you'll have something to practice before the class. So instead of plus c, this is a notation, international notation. I put a bar, and that's new for you. I'm putting a bar, and I put -1 and 3. You don't have to change the color. I'm just choosing and showing a new notation. This is notation around the world. If you show this in any country, people recognize it because they took calculus 1 class. Equals. So x3/3 is capital F. Formula says plug the top. So I'm going to plug 3. 3 into x, 3^3. Formula says minus. Don't forget that, minus. And I'll show you how to remember it in a second. Plug the bottom. And it's going to be -1. Be careful with parentheses. They are important. -1 cube over 3. And that is the answer. Now you just need to calculate what it is. So I found antiderivatives and I plug the top. Let me sign it. I will be mentioning this a lot for like several semesters. And the bottom. And this kind of silly explanation of top minus the bottom helps in calculus 3 a lot. That's why I like it. Top and the bottom. Top was 3, bottom was -1. It's not larger and smaller because sometimes it's flipped. It can be from 17 to 0. Doesn't matter, but you first plug whatever was at the top, upper limit of integration, and then you plug whatever was at the bottom, lower limit of integration. And now you carefully with people who bet with algebra, this is kind of yoga. That's going to be your problem, I think. So try your best to double check on the test. 3^3 gives you what? 9. And then minus, and you're like, okay, -1 cube is still -1. So minus 1/3. Be careful with that. And the answer is 9 plus 1/3. 9 over 27/3 plus 1/3 is 28/3. Good job. Good job, Julia. I just did it with my hand and then compared, and it's correct. Very nice. And as you can see, it's a number. It's a number. No plus C. So there's so many things I need to mention because of how amazing the situation is. But first I will stop. Did you understand the practical part of this, how to do it? Like if I threw this at you right now in 10 minutes, for example, and tell you do it by yourself, can you? Like that's the same idea. You just need to remember how to take antiderivative. Don't forget the negative sign. Many of you will forget that because it's new. And then top minus the bottom, very good, no struggle. Compare. So compare with, and now let's do what we learned before, indefinite integral. Indefinite integral of x squared dx is just x cubed over 3 plus c. So compare, that is a function. And we can ask you to find any. They both have different applications and ideas behind them, or meaning. But the process, as you can see, is the same. So students usually have a question about the very first step. Do you want to ask me that question? There's a question. I know it's there. I know it's somewhere in your brain. No? When I integrated x squared, why did I not put plus c over here, right? Plus c. And there are several explanations of that. First of all, you can just remember if it's definite integral, should be no plus c. It's a finite number. But c is a constant, so what's the problem? Well, even if I do plug plus c, here it will be 3 cubed plus 3 plus c minus parentheses 1 is 1 cubed plus c. C minus c gives you 0, so the c will go away anyways. The c got factored. The c, because of the negative sign, will be subtracted anyways. But also, it's not a family of solutions anymore. That's also another way to see it. So don't be bothered with plus c for the definite integral. And that's why students like it so much. Finally, no bother here. So another thing to explain to you is, or maybe let me make it as a note so you remember. Note, no need plus c for the definite integral. For the definite integral. That is the idea here. So what did we do here? There's so many applications. I showed you before the graph of the epidemic spreads and COVID, number of patients. Graphs looks like this. So I actually do have a graph for this function. It's a parabola, right? I draw it in Wolfram Alpha. It was very hard. That's a joke. X and Y. So what does it mean to find definite integral? So make a sketch. Here's the parabola. We're looking at the parabola y equals x squared. It's inside of this integral called integrand. So what they ask us to find is the area below this graph. If you remember, we did it before using rectangles or algebra. Half of the circle, blah, blah, blah. That's your homework due tonight. And then they ask you, no, can you do it from -1 to 3? So not the whole thing, because the whole thing is infinite. And I'm like, yeah, I think I can do that. This is the area from -1 to 0, and then from 0 to 3. I can even break it into it or not. And instead of using rectangles, left-hand point and right-hand point, midpoint, or trapezoids, we're going to learn that in Calculus 2 class or anything else, I just integrated it. And that's what everyone knows around the world. They don't remember the areas as rectangles and stuff, even though they should, but nobody does. They remember it's an integral. So I found exact, the equal sign is important. Area exactly is definite integral from -1 to 3 of the function introduced in green, dx. Exact, not approximate anymore, no error, nothing. So that's a big deal. In general, that's why it's so famous. I was told that theorem cannot be famous. People are famous. So theorem is well known. I don't know. I like calling it famous because it is. Fundamental Theorem of Calculus, that's why it's called fundamental. It changed everything. This equal sign changed the way the world operates right now in STEM. So it's very interesting that there are several things in the world that are very complicated but very elegantly simple. And this is one of the examples. That's what I was told to when I took this class, Calculus 1 class, and it's true. The professor told us, you might not understand right now, but the big picture is amazing. This equal sign worth a Nobel Prize. Such an elegant, small idea. Definite integral, areas on the left, areas, accumulation. Antiderivative on the right. Antiderivative is undoing differentiation. It has nothing to do with areas. So the idea to put the equal sign is genius. And if you check the top 10 or top 15 formulas that changed the world, that one is in the list. So that's the one that's supposed to have the Nobel Prize, but it doesn't because mathematicians don't get a Nobel Prize. Do you know that? So see it. And there's lots of rumors of why. Do you know the rumors? So we get, because there's an idea that Nobel just got mad at mathematicians, either for some cheating in his family or whatever, but it's like he specifically excluded mathematicians. Everyone can get Nobel Prize except us. So some mathematicians, they cheat and they announce themselves to be statisticians and they get a Nobel Prize. You can check that. It happened before. What? Fields medal. Yeah, we have Fields medal.
Did they win this formula win that?
I think so. Yeah, unless it was not defined yet. So the Fields medal was not there. So depends on that. I think it was not. Yeah. Post factum, I guess. So it's like a Newton's gravitational formula doesn't have a Nobel Prize, right? But that's why. So that's how important it is. Let's do one more example. And then I remember that I promised you let's see. Integral from 1 to e to the 5, 2 over x dx. And while you're writing down, I remember I promised you an appropriate joke about integrals. So we have improper integrals and proper integrals. Oh, we're going to do that in calculus too, improper integrals. And there's a term called improper integrals. But I have an inappropriate joke about integrals, which is hilarious, and I will tell you after we solve this. How to find, so step 1, I gave you steps if you want, but I don't know, people don't remember steps, they just do it. Just do it. So that's when you should not overthink this. Step 1, find antiderivative of the function inside. I'm staring at the function inside, staring at it. I see 2 over x. Antiderivative of 2 over x is 2 ln x. Do you remember that? It's not power rule. It's an exception of the power rule. Power rule works for any kind of power except -1, because x to the -1 gives you log when you integrate it. Or remember, what gave you 2 over x when you differentiated it? Log. What's the important part about the log? Oh, also I recommend you to do the steps. If you don't understand what we just did and you're afraid to say that out loud, kick out 2. I highly recommend doing that, because then you definitely see it. You see 1 over x and you're like, wait, I think I remember 1 over x comes from log. So that is going to be 2 times log of x. And then the new notation is bar and a random color. I just chose random color. This is new notation. There's a mistake. Can you find it? That might be the mistake. Ooh, nice. Several people, yes? What do you say? Good job. People notice absolute value is missing. Thank you. X here can be negative, but x inside of log cannot be negative. So to fix that, remember, when you're undoing differentiation, absolute value is there. Something like this is already on the exam. Make sure you don't forget. And the new thing is now you take this 2 ln x and you plug in the top e to the 5 minus as part of the formula. Don't forget that. Let me put it in purple. And you do 2 ln absolute value of x. And instead of x, you plug the bottom 1. And there's no plus c, which is nice. You put equal sign and you carefully find everything. So some of you would grab calculator. No, you're supposed to know this. Ln e to the 5. Ln undoes e. The answer is 5. Or 1 to the 5. 5. Several ways of seeing it. Either they kind of undo each other. It's not canceling out. It's undoing. Inverse function undoes another. Inverse functions, they undo each other. Or another way of seeing it, this 5 can go down based on the properties of log. Then ln e definitely gives you 1. So it becomes 2 times 5 minus as part of the formula. You can even put huge parentheses so you don't mess up the signs in general. 2 ln 1. What is ln of 1? Do you know? 0. E to what power gives you 1? E to the 0. So that is 0. And the answer is 10. It's a number, as we expected. If you get a function as the answer, then you messed up. Something is off. So that is the idea here. Again, we're finding areas below the graphs, or there's so much more to that. So I always kind of not big fan of explaining it as the area below the graphs. There's so much more about integrals, accumulations. But if you talk about areas, double integral will give you volume. Triple integral gives you volume and hypervolume. and so on. So that's what I wanted to explain before we move on. If I like explaining it as a CAT scan. Not everyone know what CAT scan because it's an English word. It's how do you call it? In the hospitals, they put you flat and they do the scan. No, it's not ultrasound. MRI, that's a scan of your brain. So total body scan in the hospital. So here you go. You're lying down like this, and then you hope that there's no metal stuff in your body, just because it's too late now. And then they're doing the scan. So that is integration. It's very interesting that is the idea of integration. First of all, they see that your body is from A to B. So you have already some size. It's not like it's unknown. Here's your size from A to B. That is interval of integration, where your body will be on this table. This is the size you are taking. So that's a whole rectangle. This rectangle approximates your body, size of your body. And it's a bad approximation because there's lots of parts that are extras. And then the integral goes from A to B. So it's going to be from A to B, let me change the color. From A to B, from A to B, from A to B. And that's how the CAT scan did it one way first. Now it's too much. So now to go through the shape of your body, it takes the function f of x. And this in red is a function f of x. It represents the body or the shape of the roof or the shape of the graph. That is the graph. And now it scans it down from top to bottom. Let me change the color again and put it in green. From top to bottom, from top to bottom, from top to bottom. And then both intersections give you the shape of your body, or basically the CAT scan, CAT scan. So that's like a very cool explanation of what all of this means. And that's why order matters. And dx is adding those things up. So they're all those little pieces getting added up, like rectangles or any kind of approximations. dx means adding up the widths, remember? So that's the idea. Function that is curved or something is going on. A and B is where it is located. And it's your body on the table. And then function is how shaped your body is. So that's a cool idea. And now that is the area, right? So if you do second integral, if you do one more integral from C to D, you don't have to write this down. That makes it 3D. So it's going to be Y, and height now is Z. Now your body has volume. And the scan now goes from A to B to the positive direction, from top to bottom, and from front to back. And it gives you volume. So that's what we're going to be doing in Calculus 3. So it's pretty fascinating how many applications it has. And you will be, basically in your STEM career, you'll be doing integration again and again and again and again, and too many integrations. Series functions, which we teach in Calculus 2, and integration. What do you think about that? How cool. Look at this guy in the prison, but actually it's integration. Every time people see my notes, like, Julia, what the heck do you teach? I'm like, I don't know. Some kind of, my imagination is weird. But I think the weirder it is, the more students remember somehow. Questions about this? Scanning ideas, scanning. If you put a leaf and you want to see how big it is, from A to B, shape of the leaf down. That's the area. And so on. Triple integral is not just hypervolume, but I like to explain that your lungs have a temperature or pressure that is different from other body, but also temperature is different there. So if I want a volume of your lungs, that's going to be double integral. From A to B, top to bottom, front to back. Triple integral will scan the different temperature inside of the lung from whatever temperature is highest to the lowest. And that's why there's a negative sign in the formula. Not only it gives you this idea of top to bottom, front to back, but it also highest temperature to lowest temperature, and that's triple integral. So integration accumulates things, qualities of an object. Area is just one of the qualities, temperature, gravitational forces, all of these are integration. So that's why it's so cool. That is the idea, it's so fascinating. Well, okay, now I can give you the inappropriate joke because that helps people to remember the notation. Remember, you're not supposed to randomly forget. You don't have to write it down, obviously. So you're not supposed to forget the notation of f of x dx. That is important. You keep to, many students don't write the x, that's not correct. How do I know if I put -4? Is it -4 inside of the integral or outside of the integral? So this thing is important. Not only has meaning, infinitesimals, if you know this word, it accumulates infinitesimals, but it also has a good notation. So a teacher goes to school in a not very good neighborhood, and on the way to school, he or she, a teacher sees all those graffitis on the walls, and lots of weird graffitis and everything, and some of them are not good. And he just stops at one, the very bad one, and he's like, oh, those students, come on, are like so wrong. It's also so close to the school. So he gets very upset, and he takes a chalk to fix it or to erase it. And then he sees this, and he's like, no, why would you write it down close to school? He's like, I told you so many times, don't forget the x at the end. It's genius. It's an amazing anecdote. So don't forget the x at the end. I like this joke a lot. And also, this joke is international. You can tell it in any country if you think about it, and they will understand. How cool is that? People like explaining to each other. Like, can you explain it? Now you regret you asked. I can do more examples on Wednesday, but right now I want to show you average function value before we move on. Let me make another video for that.